இப்போ no, I don't have to see this. All right. Hello, Sri Balaji Ravi. Needanappa. Okay. Hello. So I got a few questions from people. Are these people here? Shweta, Bajaj, Yati Payal, Indu, Darshak, Ankit. Are these people here? So anyone coming in and logging in, please say hi, introduce yourself, and then I'll answer your questions. Hi, being Dasher, YouTuber, how are you? So did you have a question? Dashing. Nine people watching now. So okay, 8 are watching now. Are there any questions? And if there are these people who have asked the questions, please introduce yourself so I can start addressing. Right. Shweta, Bajaj, Yati Payal, Indu, Dashak Mehta, Ankit, Didwania. And if there are any other questions, please do ask in the chat window and I'll be happy to answer those. Right. Okay, Gautam, go on. So Gautam says that he has a question or some clarification regarding immune reaction in myasthenia gravis. So what's your question, Gautam? Okay. So Gautam says that I want to know how the damage to the nerve cells are caused, and I think he will type the rest. Let him finish the question and then I will answer. Okay. In the meanwhile, there's another question from Achint. I'll answer that question first, and then I will come back to Gautam's question. So Achint is asking, I'm a PhD student in theoretical neuroscience. While I found the first week good, the second week seemed too detailed and factual. Can you please add some mathematical modeling to the course? The answer is no. This course is structured by the syllabus that is provided in the beginning of the course. This isn't a course on theoretical neuroscience. This is more of a course on neurophysiology. There isn't going to be much mathematical treatment of this content in this course. So, this is a course that focuses more on the physiology part. Although it is called as neuroscience of human movement, it is essentially a course on uh, movement neuroscience from a neurophysiology viewpoint. So there will be less mathematical treatment and more of factual, physiological, functional content. Did I answer that question, Achint? Thank you, Achint. You're welcome. Of course, I hope that doesn't make the course boring. Maybe it's not relevant for a student from your background, coming from theoretical or computational neuroscience. You probably expected mathematical treatment, but you there is still some content that you can gain from in this course, I hope. So please stay on with us. That's my request. So in the meeting, Hello. Now it's okay. Now it's okay. Banu, Kartikeyan, Pankaj, Pankaj Keshari. Now are you able to hear me?
Yes, sir. Fine, sir.
Yes, fine. Okay. I'm hoping that that this problem is just a small problem. Now, coming back to Gautam's original question, which was on myasthenia gravis, right? So the question is, what is the immune system mechanism, right? So how is the damage even caused? So that's the question. So what happens is that the immune system has a method by which it marks particular external agents for attacking, right? And then there are multiple methods by which these external agents are attacked. Many of these are chemical, right? So the regular methods of chemical dissolution of specific cells are used, right? As to why particular glial cells are marked as external agents, it is not clear. So first, let's remember what's the let's remind ourselves of the details of the physiology here. First is that the neuron itself is not affected. The axon is less affected in the usual case. In most cases, it is the glial cell, either the Schwann cell in the case of GBS, or the glia oligodendrocyte, or this in the case of multiple sclerosis. Right? Oh, the question was on myasthenia gravis, right? So that's what happens in multiple sclerosis and GBS. But in the case of myasthenia gravis, what happens is the question was on myasthenia gravis. Sorry, there was substantial confusion. There were several people coming in and going out, and oh yeah, the question was on myasthenia gravis. So in the case of myasthenia gravis, what happens is that the the nicotinic cholinergic receptors are the ones that are affected, right? So in this case, the immune system marks the nicotinic cholinergic receptors as the possible external agent. Right? And then the other systems that take care of the damage this. Many of the topics are not covered in. Many of the topics covered in week 2 and 3 are not covered in the recommended text. Okay. Achint, I'm going to answer that. But before that, let me finish myasthenia gravis part. So in the case of myasthenia gravis, it is the nicotinic cholinergic receptors that are getting affected, right? So as to why that is caused, then why exactly this system is getting marked, that's not clear. So if you block the nicotinic cholinergic receptor from functioning, then acetylcholine cannot activate this receptor, and then sodium cannot enter inside. Then the rest of the story, same thing, right? Essentially, sodium cannot enter inside, and it cannot cause an action potential in the muscle fiber, right? Now I will Nila Revati, please, I'll answer questions one by one. First, I'll answer the questions by Achint. Achint is saying that many of the topics covered in week 2 and 3 are not covered in the recommended text candle. Can you please recommend some other text to follow along with the course? Okay. The first week, for example, I think not first week 1 and first 2 weeks, but just the first week content is better found in physiology text. I think that was also mentioned in one of the discussion forum points where I posted that in the first week. I said that for the first week, please follow Physiology by Costanzo or Vernon Levy uh, or by Guyton. I think this was posted in the discussion forum. If you are following the discussion forum, I posted this 2-3 weeks ago in the beginning of the course. I posted this saying that please look at physiology text for the first 1 or 2 weeks of the course. After that, I think Candle will catch up. After some time, there are 1 or 2 topics such as oligosynaptic reflexes or polysynaptic reflexes and pre-programmed reactions. Right. At that time, again, you will not find this content in Candle and Schwartz. But for most other content, Candle and Schwartz will work. Right. So physiology texts such as Linda Costanzo, Guyton, Vernon Levy will work for you for the first. That was Burn and Levy. Burn and Levy, not Burns. So now Gautam says, thank you. You're welcome, Gautam. I got this confused between multiple sclerosis and myasthenia gravis. There are just too many posts. So I hope I answered your question. Nila is saying a whole bunch of things. She says, it would be great if you are provided with lecture materials for reference. Yes, I agree that it would be great if we are providing this. We will try to get this done. As and when it is available, I'll have it uploaded. Since this is the first time we are offering this course, getting this transcribed is taking some time. This is a part that is outsourced from NPTEL. NPTEL is already overloaded with so many courses that it is running, 270 courses. They don't have permanent staff to do this. So we are getting this done by outsourcing, and that means that we are dependent on somebody else's efficiency. So however, we are working on this. As soon as the lecture transcription is available, we will provide it. So is that what you're asking, Revati? Hello. Yeah, I think now it works. Yes, I hope it's now working. Hello. It's okay now. Okay. So going back to Revati's question, she is asking for lecture materials. I hope she is meaning transcription of the lecture. We are working on that. We will provide it as soon as it is available. All right. Some questions. Okay, there were actually 3 questions in the first 2 weeks of assignments that had some mistakes. We corrected those. For the 4th week and the 3rd week, we have corrected those. And the 5th week and 6th week, I have had it reviewed multiple times. So in future, this kind of mistakes will not be there. I am personally looking into this over and above what others are doing. So hope this kind of problems will be avoided in future. as always, kindly provide your feedback and let us know if whenever there is a problem. And please, let me assure you that I'm going to work with you on this. If there is a problem, I'm going to try and now fix the problem, or somehow try to help you in the best possible way to your satisfaction. So don't worry about giving feedback all the time. So just write to me saying that, or write in the discussion forum, which I prefer. I do check the discussion forum every day. So please do write in the discussion forum saying that there is a problem, and I will respond. If I say that in response that, hey, I am aware of this and I'm going to work on this, no need to keep on repeating the question then, because there's not much value that is getting added. If I'm saying I'm going to work on it, you can take my word on that. Is that okay? And okay, are there other questions? So I don't know if these people who had asked the Karthikeyan is asking, sir, could you tell us about your research and neuroscience? I'm going to say that, but there is a previous question from someone. I'm going to answer that question first. Pankaj Keshari, how psychophysics is related to this course? Okay, very little relation to psychophysics with this course. The only part where there is a relationship is where we talk about cutaneous receptors, right? So it turns out, okay, again there is some audio problem. Nila is saying she's not able to hear. Okay, let me check, just 1 minute. Hello. Okay. Okay. So when we Hello. Okay. I think now it's fine. Every once in a while, I think my computer is freezing up, and I'll have to go back and change the audio options. I think now it's working. Yeah, that's okay. So it's working now. I'm going to proceed. If the problem persists, I'm going to go back and change a different mic. Okay. So let me proceed. I think it's now working. So psychophysics, right? So motor function depends on how we perceive the world. In particular, in the case of hand and finger functions, right? There are cutaneous receptors that are used to perceive the world, how the objects are oriented. For example, what is the texture on the object, how smooth the object is, to a large extent influences the motor function. But if the question is how is psychophysics itself related to neuroscience, that's a different question. Here we are talking about motor science, or motor neuroscience, or movement neuroscience. Movement neuroscience is related to psychophysics to the extent that it can influence motor function by perceptual changes. So through psychophysics, I think what is being asked is perceptual psychophysics, I hope. Okay. Then there is a question on my own research on neuroscience. So I am working in behavioral neuroscience, in neuroscience of movement, specifically of hand and finger functions. In future, in one of the classes, I think that's in That's in a specific class dedicated to hand and finger control of so that's specifically dedicated to how neurons in the motor cortex control hand and finger function. In that, I'll be talking about my own research, but briefly here. So we use the hand and fingers as model systems for movement. So by that, what I mean is that if I can study hand and fingers, I have essentially understood how the other movement systems function. So if I can study hand and fingers, that means that I have also understood how the leg works, or how the shoulder works, how the face works, to a large extent, how the neck works. Because the hand and fingers for us is a sufficiently rich and complicated system. By studying this, I can understand how the rest of the movement system works. But we primarily work on mechanics, so we measure mechanics, we measure forces, we measure displacements, velocities, accelerations, are, in other words, what people from the field of mechanics or biomechanics would call as kinematics and kinetics. So much of our work depends on knowledge and applications of mechanics. This is the reason my lab is called as the neuromechanics lab. So we rely on and measure fingertip forces and finger movements in manipulating objects and in working with pre-shaping and approaching an object for manipulation. I hope that is clear. More information on my work is available in my website. That link I'm now sharing with you. Okay, it is saying remove any web addresses and try again. It says. Okay, you can just Google for neuromechanics lab IIT Madras. You will find it. So it's available. I'll also post this in discussion forum. All right. Those who are interested can check. Are there any other questions? Nila, did I answer your question? So we are working on the lecture notes part, and we will check the assignments before posting them. We will check it multiple times, so you will have less problems. Thanks for staying in the course. So Karthikeyan, kindly check my website by Googling, because I'm not able to put a web link in the chat window, but I'll also post it in the discussion forum. Right. So, okay, I will try to answer questions that have come through the form, Google form. If those people who have asked the question are here, well and good, they can get the answer. If not, at least I hope others who are having the similar questions will benefit from this. All right. In the meanwhile, if you're having some questions, please type in and I will catch up with them, because I have about 4 or 5 questions. Okay. Karthik, I'm going to answer your question in a bit, because I'm reading the other question from Shweta. How neuroscience relates the human movement to humanoid robots, as based on neuroscience, humans try to manipulate machine learning concept. All right. I think the question is, I'm translating that to my understanding. I think she's asking about how human movements and robotic movements are related, and how by understanding human movements, we can manipulate robotic movements, how we can learn to produce better robotic movements with the help of understanding of human movements. I hope that is the question. Okay. The purpose of one major purpose of this course is to try and help you understand and appreciate the fineness, the dexterity, the smoothness with which the human movements happen. Robots do make movements. Actually, in many cases, robots do many movements better than us. But that doesn't make them as versatile as us. If you take a look, you will realize that we are able to manipulate relatively small objects with relatively small forces, and also we are able to pick up and manipulate big objects with larger forces. So essentially, robots can work in a relatively small range of forces and a small range of displacements with small requirements of dynamics, whereas humans can work in relatively larger ranges and have higher resolution. So essentially, the way I'm answering it looks to you as if the humans are very good or much better robots, but it's more than that actually. By understanding human movements and especially the concepts and the ideas of dexterity, smoothness, and how or what is the source of this dexterity, what is the source of this smoothness, what is the source of this flexibility, we may be in a position to come up with not just better mechanical robots, but also, I hope, at least from this course point of view, we'll be in a position to come up with better control algorithms. Now that's different from saying just building better robots. Coming up with better control algorithms is possible only if you understand how the human system is controlled. To a large extent, we understand only a little bit about um, how human movements are controlled. Whatever understanding of human movements control is there, that is taught as part of this course. At least it starts the foundation for this course. Okay. Now I'll go back to Karthikeyan Swaminathan's question. And that is on how are we conscious about the movements we make. I think this topic is discussed at length in one of the future classes. I think that is week 4 or week 5. I think within the next couple of weeks there will be a discussion about muscle spindles and Golgi tendon organs, which are essentially receptors that measure body position, which is proprioception, and body movement sense, which is kinesthesia. So both kinesthesia and proprioception are possible by interaction of these multiple receptors and cutaneous receptors. So these are topics that we deal with in the future weeks. So please stay on in the course, watch the videos, read the book, and to a large extent, you will understand how we are conscious about the movements we make. Now, that's the theoretical answer to that question. But if it's a philosophical question, how are we conscious? Then the answer, I will start the answer with, are we conscious? Because many times we think Yati Payal says that there is a problem on my end for the last 20 minutes. Check that. Yati, if you're not able to watch it, we will put up the recorded version for you to watch, and I will answer your question. So let me continue with the question. So maybe we are not even conscious. Many times we think we are conscious, but we are not conscious. In other words, the decision to move has already been made, and after the decision to move has been made and it is getting implemented, you become aware of it. The question of how conscious we are and how much in control we are all philosophical questions, and this is a topic that is still being hotly debated in the field as to, are we even in complete control? See, this is weird because we like to think that we are in control. We like to think that we are in charge. We like to think that we are conscious of what we are doing. However, decisions are made, and commands to make those decisions, commands to implement those decisions have already been given. Only after that we even become aware of that. So by conscious, if you are talking about awareness, right, by conscious, if you mean awareness, awareness by itself doesn't mean consciousness. So there is more to that. There is more than that. So I hope I have answered that question. But in the next couple of weeks, I think in the 4th or 5th weeks, there is a discussion on receptors, right? So that is how we understand how we move. And actually, these are relatively accurate sensors of length and force. Surprisingly, how do these sensors work? So these sensors are in the body. How do these sensors work? That is the question. Please watch the videos. The answers are there. Okay. Then I'll go to another question by Gautam. I'm really naive and have got less exposure to neuroscience. Can you suggest a learning source, book or online sources which deals on the basics? All right. This is a good basic course. You'll have to put some fight in watching this video. Each video for you to watch, it takes some time. Actually, it takes more time, I realized, than the video time. So if the video is for 1 hour, you end up watching the video and taking notes. If you're properly taking notes and learning, it will take you more than 1.5 hours. I expect that it may take up to even 2 hours for every 1 hour of video. So this is a course that takes you from the basics. And if you watch the video, take the notes, and then refer the appropriate texts that are announced, right? For the first 2 weeks, it is actually physiology texts such as Bernon-Levy, Costanzo, and Guyton, and then Candle and Schwartz. So if you read Candle and Schwartz after watching the video, you will understand it very well. There is substantial clarity in reading Candle and Schwartz after you watch the videos. But if you are directly reading Candle and Schwartz, you're going to find it very difficult, because it's very theoretical, very dry treatment of the subject. So my request is, please watch the videos, take the notes, then read the book, and then review the content. You will realize it. You will be in a position to understand this from the basics. All right. Now to the question on neuropsychoanalysis. I actually don't know what it is. I'm not in that field, psychology, psychoanalysis. So I'm sorry, I'm not in a position to answer that question on neuropsychoanalysis. Pankaj Keshari, I'm not able to answer that question, because we work on movement neuroscience. This is a course on movement neuroscience. And when it is psychoanalysis, I suppose you are talking about the Freudian type of psychoanalysis. I think I would refrain from answering questions on topics that I know very little about. Please excuse me. So I'll continue answering the questions that have come to me on the form, on the Google form. All right. So the second question is CNS fine-tuning of voluntary movement. Okay. Yati, are you able to hear me? Yati Payal. If not, you can watch the recorded version. So CNS fine-tuning of voluntary movement is a topic that is dealt with after the 5th week. From approximately the 6th, 7th, and 8th week, fine-tuning, fine control, movement selection, and movement error correction, online error correction, are forming part of the second half of the course. From about 5.5 or from 6th week onwards till about 12th week, the entire content is on CNS fine-tuning of movement. All right. Before that, weeks 4, 5 are on reflexes, approximately. All right. So CNS fine-tuning is something that's going to come up in future. So I will deal with it at that time, and we will continue to have hangouts like this if there is sufficient response and interest. Okay. Somebody has asked the following. Darshak Mehta has asked the following question. I'm working on a project, brain-computer interface, which demands to deal with recognizing brain waves when human movements are detected. What factors are there to be considered when working on these aspects? Well, okay. Brain-computer interface is something that isn't completely related to this field of this course. We have one particular lecture coming up in the future, much later, I think in the 8th week or something like that, where we talk about or what kind of systems are to be used, or what are the advantages of using such systems. But I'll briefly answer this question here now. The question is, I hope the question is, what is to be taken care of? What is to be, what are the things to be careful about? I think that is freezing, or is it even working? Hello, hello. Okay, I guess it is working, but the video is frozen. Video is frozen. Huh? Is it? Okay. Okay, I'm just refreshing for a minute, please. There's okay, it's working. Okay. So, what are the things to be careful about in design of a brain-computer interface? Well, okay. Essentially, the idea is, I hope to build artificial movement systems that can detect intentions. So essentially, the brain will have waves, or specifics will produce specific signals that signal an intention to move, and then using electromechanical systems like a robot or like a prosthesis will produce a movement, is the hope, right? Or in that is in the case of a prosthetic devices, have we will have movements made on the screen, or we will have buttons clicked on the screen, or we will have choices made on the screen, or alphabets typed on the screen. All these things are examples of brain computer interface. The question is, what are the things to be careful of about? So the answer to that is, essentially, I hope we will be dealing with non-invasive measurements of these, right? So multiple approaches exist. One is to use EMG-based approaches, or movements in remnant muscles, or whatever muscles that are working. The other is to use brain waves, or EEG based approaches. What's coming up now is the approach to combine information from brain waves and muscle electrical activity. So essentially, fusion of data from multiple modalities. Note that these two are of different types, different amplitudes, different properties. Combining this are what is called as I mean, in engineering parlance, this is called as sensor fusion technology. Very hot topic. So the moment you say sensors and sensor detection control, that's one. The moment you say sensor fusion, everybody is raising their eyebrows. Oh, it's something. So what this means is essentially combining information from multiple modalities to make sense of what the system, what the remaining system is trying to do. What are the things to be careful of? Well, obviously, the things to be careful about, the things to remember are the regular things that you should be careful about recording EEG or EMG for, right? So, avoiding noise, having a system that is resistant to noise, so relatively good hardware and software that takes care of avoiding noise, and relatively sophisticated algorithms that classify specific decisions, right? Obviously, these things also are decided, right, to some extent by the by how well you understand the decision, and how much can you train the patient. The patient must be trainable. If the patient is not able to learn your system, then I think there is a limit to how much you can help the patient. I hope I've answered that question. Okay. Okay, Achint question: will learning of motor movements with experience be discussed later in the course? Yes, that is addressed in 3 parts. In the topic on primary motor cortex, there is learning that I'm talking about. That is the unsupervised learning that is discussed. Then in the topic on basal ganglia, we discuss about reward-based learning or reinforcement learning. And in the topic about cerebellum, we talk about error-based learning or supervised learning. All right. So I hope I answered that question. So learning, all forms of learning that happen here in the system are discussed in later in the course, and and at sufficient depth, actually, sufficient depth. Right. Gautam is asking a question on microfluidics, which I don't understand. Microfluidic chips are used to culture cells and imitate organs in a chip. Is it possible to culture neuronal cells in a small microfluidic chip? If so, it would be a great breakthrough, isn't it? I am not an expert in this field. I am unable to comment on that. I do not understand what is microfluidics. I know that it's a hard field, so you can do whatever you want. And if you try to say that that is microfluidics, there's a good chance that you get funded. I'm just joking. I actually don't know about that. It's a hard field, so people like to use that. But I think to actually make a breakthrough, you need to go sufficiently deep enough, whatever that field may be. Okay, so let me go back to the questions I get in the form. I got in the form. Okay, Ankit Didwania is asking the question: how can it be used in research for accessible technology for disabled? Right. Again, uh, if it's a disabled person and you're trying to help that person, you can do it in multiple ways. One is by using brain signals and classifying brain signals and understanding intentions. The other is by using remnant muscles. For example, movement of the shoulder could signal movement of specific fingers. The third is to use a more sophisticated method whereby you measure both movement of the muscles and the movement of and the activity of the brain by EEG, and combining that using sensor fusion or advanced signal processing techniques. Brain computer interfacing and building assistive devices for disabled people usually involves sufficiently deep understanding and detailed signal processing algorithms. Okay, so that's more of signal processing. You can start. Okay, I think we are back on air now. I hope some technical problem. I think we are back on air now. Are there questions? Okay, I'm going back to the questions from. Uh, yeah, we were talking about technology for the disabled, right? So that question I have answered. Brain computer interface question I have answered. CNS fine tuning of voluntary movements I have answered. How neuroscience relates to human movement and humanoid robots I have answered. And there was only something which Indu has asked, and I'm not able to understand that question. I'll just read it. She just says numerical problems. Well, numerical problems are related, are there only in the first week, right? So this is more of a course on physiology. This is a storytelling course. I tell stories, you hear stories, you recreate stories, and you tell stories. So this is more of a functional course. There is little mathematical treatment. But that doesn't, of course, mean that it is less relevant or less useful. So different courses have different focus. And please stay on with the course and check out. There is probably something for you to learn and pick up from. Okay. So I'm going back to checking if there are questions that I have not answered. I'm not able to find such questions. So far, I think I have answered all the questions that are asked in the chat channel and also in the form. All right. So one thing, I have a request for all of you. There are about a few people who are watching, and those who are watching silently, I see that some of you are logged in but not actually asking a question. That's okay. That's fine. Everybody, please do check the forums where I actively participate. It seems like some of you are not accessing the forums. From talking to you, I get that picture, because you are asking questions that have been answered in the forums. It's possible several critical course related information are posted in the forums. I request you to please log into the forums, read content, and ask your questions there, and check for course related announcements and information in the forums. You will benefit from that. So please, I request you to do that. Okay. We have about 10 minutes. I don't mind staying back for a few more minutes if there is sufficient interest, though. So I know there is there is sufficient enthusiasm here. People want to go into reflexes, voluntary movements, how to detect that, how to use this for building a robot or a prosthetic device. These are the applications of this course. I see that that's the kind of interest, and that's the kind of question that I'm getting. But again, to get there, you need to understand things from the basics, and I am making an attempt to teach this from the basics. So your foundation must be sufficiently strong, and we are in the first 2-3 weeks, and this is your foundation. You need to be patient. So continue to read, continue to watch the video, continue to put your effort and fight you and invest your energy. And I hope that this foundation will help you understand the advanced topics in the second half of the course much better. So I think that's an important part of the message that I wanted to convey, right? Okay, I'm checking for questions, and I'm not finding it. Okay, I'll wait for a few more minutes before we wind down. Let me check the syllabus so I can give you an idea of which week is which content, right? So so receptors are there in fourth week, such as muscle spindles, Golgi tendon, organs are fourth week content. So if someone asked how conscious are we about the movements, and learning primary motor cortex, CNS fine tuning are all going to be in week 6, 7, 8. Learning is a recurring theme that happens in multiple weeks. It happens in the cortex. Unsupervised learning is known to happen, or is believed to happen in cortex. That is in week 6, 7, 8. And supervised learning or error-based learning, error-correcting learning is believed to happen in cerebellum, week 8 and 9. And reward-related learning or reinforcement learning is believed to happen in basal ganglia. That is week 11 and 12, the last 2 weeks. So learning is something that is going to be there throughout. It's a topic that is going to be there throughout. How do we learn to perform exquisite movements, say artistic movements, or say aesthetic movements, or athletic movements? How do people become good at it? What are the to some extent, again, we are only setting the basics for you to go to advanced topics. We are setting a very strong foundation so you can go out and read independent literature. So if you do this course, if you finish this course, by the end, you will have sufficient confidence to actually answer questions and actually ask more intelligent questions and read research literature and understand and appreciate and come up with deeper design questions. All right. Again, Yeti, I'm not able to understand that question. Sir, can you please explain CNS mechanism? What does that mean? CNS fine-tuning of voluntary movement is what she asked. That's going to be in dealt with in future classes from about 5th week as per syllabus. By the way, let us remember, reflexes are also CNS responses. Reflexes originate in the spinal cord, and spinal cord is part of the central nervous system. Central nervous system doesn't necessarily mean or refer only to the brain. So from about week 5 to the week 12 is the CNS fine-tuning of voluntary movement. That's the entire course about. So, well, if you're talking about voluntary movement, then we'll have to define what is voluntary movement. Then again, from about week 6 or week 7, we start out with a discussion on primary motor cortex. Okay. So fine-tuning of voluntary movement by cerebellum would be added in the course, is what she is asking. Yes, that is error correction by cerebellum will be part of the course. That is in weeks, I think 8 and 9. That is week 8 and 9. Yeah, that's coming in later, much later in the course. That's because we have to build the foundation for you to understand and appreciate that. So there is going to be some amount of fundamental physiology that is discussed now, which will help you to understand and appreciate that content in future. Okay. Of course, if you are reading from Candle and Schwartz, you'll realize that some parts of the movement subsection are not covered, such as eye movements, such as vestibular system, and a few other chapters are not covered. That's because there isn't sufficient time. In 12 weeks, this is how much we can do. And if you do this course, and finish reading the relevant chapters in Candle and Schwartz, after that, you will not be afraid of touching Candle and Schwartz. Candle and Schwartz is this monster, a very big book, a huge book that you're usually afraid of touching. My goal and my aim and objective is to remove this fear of reading from Candle and Schwartz. If you watch my videos and then read Candle and Schwartz, then after that, you will not be afraid of Candle and Schwartz. Otherwise, you must be super motivated. You must be an extremely motivated person to take Candle and Schwartz by yourself and read and understand and appreciate. That is also possible, but only for a few of us. Right? Not everybody can do that. So that's the idea. Okay. It's about 1 o'clock. Are there any other questions before we wind up for the day? We will have more of these if there is sufficient interest in future. Okay. So, uh, if there are no questions, I would like to thank all of you for dropping by and staying with us and asking questions. I hope I have cleared some of your doubts. I hope I have answered some of your questions. Uh, we will have this more frequently. We will have this once every 2 weeks. Once, I mean, every week would be. Okay. Hello. Hello. Okay. I think now it's coming. Will you also touch upon disorders? Is what she's asking. Like we have done so far, like we have done with myasthenia gravis, multiple sclerosis, GBS, Lambert-Eaton syndrome, like that. To that extent, we will touch upon disorders. In basal ganglia, in cerebellum, in primary motor cortex, there is sufficient discussion, relatively deep discussion of the disorders, right? So disorders are discussed relatively deeply in future part of the course, but not as separate topic, as part of another topic, right? Where can we get syllabus for the course? The syllabus for the course is available in the course website. Unfortunately, I'm not able to put up links in this chat window. But if you go to onlinecourses.nptel.ac.in, NOC 18 underscore G13 course. All right. So that's where it is. Uh, Please do check that's where in the course homepage, after an introduction, there is a course layout that says week 1, week 2, week 3 until week 12. What is the content? All right. So that's what I mean by syllabus. Okay. All right. So if there are no other questions, I think again, I'll thank all of you. Thanks for participating. And I know some of you asked questions, some others are actually silent. Thank you for participating. We'll have more of this in future. Please do send your questions. Please ask your doubts in discussion forum. Read discussion forum before asking questions, and then ask other questions. So thank you very much. Kindly continue to actively participate in the course related activities and benefit from that. I hope that some of you will also take the exam. Please do prepare for the exam. It is going to be multiple choice based as your assignments. So you must expect questions at the depth at which assignment is asked, at least at that depth. Of course, you should watch the videos and read text and aim to go much deeper. See, the idea of taking exam is to give you feedback, not to get a grade. So please enjoy the process. So hopefully you will then get a good grade. Best wishes, all the best.